Hi everyone, we're going to establish trig identities using factoring. In this case, we're going to be using the fact that a plus or minus b squared equals a squared plus or minus, I'm going to write this down here. So basically, a plus or minus b squared equals a squared plus or minus 2ab plus b squared. Because what we have here is a plus b squared, and this one is a minus b squared. So I'm just going to use the formula. Sine is my a, and cos, oh, I wrote this down wrong. So this shouldn't be squared here, it should be out here. Okay. So basically this is what we're using. So my a is sine, and I'm just going to use this formula. So for this one, that's going to be sine squared, because that's my a, plus 2 sine cosine, I'm using the 2ab part, plus cosine squared theta, which is my b. Then I'm going to do the same thing for that. It's the same thing, but we have a minus. So we get plus sine squared again, minus 2 sine theta cosine theta. I always never leave room. And my last one's going to be plus cosine squared theta. All right? And when you look at this, these two here cancel out. So let me rewrite this. We have sine squared of theta plus, let me just go ahead and put these two together, plus sine squared of theta. Then I'm going to put my cosine squares together, plus cosine squared of theta. Oh, by the way, this equals 1. This equals 2, not 1. Sorry about that. Plus cosine squared of theta. Now, we have 2 of these, so I'm going to write 2 sine squared of theta. And I have 2 of those, plus 2 cosine squared of theta. I'm going to factor out a 2, because they both have a 2 here. So I get 2 times sine squared theta plus cosine squared of theta. And this here, from your Pythagorean identity, you know that equals 1. So you get 2 times 1 equals 2. And so we have the 2 here, so we have 2 equals 2. And that solves that. Okay, the next one is this one. So the first thing I want to do is, this is supposed to equal 1. So I'm going to write this as sine squared theta over cosine squared of theta. There's really no factoring involved in this one. I guess I stuck it in here. And this one is cosine squared of theta over sine squared of theta times sine squared of theta. This one's just trig ratios. Now, these cancel out. Do a different color. These cancel out. So we get sine squared of theta plus cosine squared of theta equals 1. You know that equals 1. So 1 equals 1. And the next one is, this is a 4. Secant to the 4th of theta minus secant squared equals this side. And it doesn't matter what side you use, because both are quite complicated in a way. So what I'm going to do first is I'm going to go ahead and use this side, because it's on the left side. I'm used to that. I'm going to factor out secant squared. It's my highest common factor or greatest common factor. And then you're going to get secant squared of theta minus 1. And remember, it's supposed to all equal that. Well, secant squared equals tan squared of theta plus 1. So basically I substituted this. And I keep looking at this here. And this equals tan squared. So there's my two substitutions. Now I'm going to go ahead and distribute, and I get tan to the fourth of theta plus tan squared of theta, which that's what it equals. So I'm just going to write it again. Tan the fourth of theta plus tan squared of theta. Right? And the next one's the same way. So we're going to go ahead and factor out cosecant. You ought to try this one on your own and pause the video, but it's the same as the other one. You have cosecant squared of theta is cosecant squared of theta minus 1 after you factor it out. We want it to equal that, so we keep that in mind. And this equals cotan squared of theta plus 1. I wanted to put that in red. And this one equals cotan squared theta. Now when you distribute, you get, I'm going this way, you get cotan to the fourth theta plus cotan squared of theta, which equals our desired result, which is cotan to the fourth of theta plus cotan squared. And we established the identity. Okay, the next ones we're going to do involve multiplying by the conjugate. Thank you and have a nice day. Bye-bye.